Hello and Assalamualaikum. My name is Syariatul Adawiyah binti Cik Azlan from class A1. So for this presentation, I will talk about the introduction and the objective for the topic that we have chosen for our assignment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sarah binti Yusof from group A1, and in this assignment, I'm going to explain about the problem statement, the solution and the conclusion. That's all. Thank you.
Introduction. The distance formula is a formula used to find the distance between two distinct points on a plane. The formula was derived from the Pythagorean theorem, which states that for any right triangle, the square of the hypotenuse is equal to the sum of the square of the two legs. Finding the distance between two distinct points on a plane is the same as finding the hypotenuse of a right triangle. From this perspective, the distance formula states that the distance of two distinct points on a plane is equal to the square root of the sum of the square of the rise and run. This distance formula comes with some uses in everyday life. It can be used as a strategy for easy navigation and distance estimation. For example, if a pilot wants to know the distance of an incoming plane and his plane, he can use the plane radar and find the coordinates of two planes and then apply the formula. Objective. First, to calculate how fast is the distance between the ships is changing. Second, to interpret derivative as a rate change. And third, to find the distance x and y.
This is the question that we decide to discuss about. At noon, ship A is 150 km west of ship B. Ship A is sailing east at 35 km per hour and ship B is sailing north at 25 km per hour. How fast is the distance between the ships changing at 4 p.m.? From the given question, we know that A moves east at 35 km per hour. So, we let x equal to distance travelled by A at time t, while B moves north at 25 km per hour. So, let y equal to distance travelled by B at time t. We know that x is increasing at 35 km per hour, so dx over dt equal to 35, while y is increasing at 25 km per hour, so dy dt equal to 25. Since A has sailed east, the remaining distance to BO is 150 minus x. We need to find the dd over dt at 4 p.m. So the t, which is the time, is 4. As we can see from the diagram before, the point A, BO and B is a right angle triangle. So we can find the d by using Pythagoras theorem. After substituting the information that we got from before, we got d squared equal to 150 minus x squared plus y squared. But because we need to find the dd over dt, we need to differentiate the formula with respect to t. Then, to find the distance of x and y, we have to multiply the distance of both ships by 4. The distance of x is 140 km, while the distance of y is 100 km. To find the d, we need to substitute the value that we've gotten before to the original Pythagoras theorem formula to get square root 10,100. Finally, we substitute the value of d to solve for dd over dt in the formula that we had differentiated before. Thus, at 4 p.m., the distance between the ship is increasing at the rate of about 21.39 km per hour. In conclusion, the formula of Pythagoras theorem is a squared equal to b squared plus c squared. After applying the formula according to the information that we got from the diagram in question, the formula becomes d squared equal to 150 minus x squared plus y squared. To find the speed of ship at 4 p.m.,
we need to differentiate the equation with respect to t and use Pythagoras theorem to find the distance of x and y, which is 140 km and 100 km, and find the distance of d, which is square root 10,100, and substitute to the formula that have been differentiated before to get how fast is the distance between the ships changing at 4 p.m., which is increasing at the rate about 21.39 km per hour. That's all from us. Thank you.